Every time you fill a car with gas, board a flight, or fly a package across the world, you're relying on a molecule that has to travel thousands of kilometers before it ever reaches you. Oil doesn't come from where it's used. It comes from a handful of regions, gets loaded onto tankers, and crosses some of the narrowest, most heavily trafficked stretches of water on the planet before it reaches a refinery near you. One of those stretches is barely 3 kilometers wide at its narrowest point. Every day, more oil passes through it than through almost any other waterway on Earth, enough to fill over 20 million barrels, one after another, in a single 24-hour period. For most people who've never shipped a barrel of anything, that number is hard to picture. Try this instead. It's roughly equivalent to draining an Olympic swimming pool of crude oil every 3 minutes, all day, every day, just to keep one narrow channel moving. That channel is the backbone of an entire global supply chain, and for the country that depends on it more than almost any other, it's also a single point of failure. But here's the part most people never hear about. That country imports somewhere around 70 to 80% of all the oil it uses, and the overwhelming majority of it has to pass through that same narrow stretch of water to get there. It's not a backup route. It's closer to the only route, which means that stretch of water isn't just infrastructure. It's a pressure point that planners have spent 2 decades quietly worried about. In 2003, this vulnerability got a name inside Chinese policy circles, the Malacca Dilemma. 2 decades later, it still hasn't been solved. China now consumes more than 15 million barrels of oil a day, a figure that has roughly quadrupled since the year 2000, and nearly all of the imported share still arrives by sea, through that same choke point. So while the rest of the world has been watching China build solar farms, battery factories, and electric vehicles, a quieter industrial build-out has been happening in parallel, one aimed not at the electricity grid, but at the oil tanker itself. At a facility in Hami, in China's western Xinjiang region, the country's largest coal producer has committed $24 billion to something that sounds almost like alchemy, turning solid coal into the same liquid fuels that come out of an oil well. If you're into stories about the unglamorous infrastructure quietly reshaping global energy, stick around. Hit like and subscribe so you catch the next one. Why hasn't this been done at scale before? The honest answer is that it has been tried, and for a long time it didn't make economic sense. Turning coal into liquid fuel isn't a new idea. Chemists first demonstrated it in the 1920s, and it saw real industrial use nearly a century ago, when a fuel-starved wartime Germany needed a way to keep vehicles running without access to oil. The chemistry behind it comes down to one basic mismatch. Crude oil is naturally rich in hydrogen relative to carbon, which is exactly what liquid fuels need. Coal is the opposite, heavy on carbon, light on hydrogen, sitting at roughly a 20th of the hydrogen content oil has by comparison. To turn coal into something a jet engine or a car could run on, engineers either have to strip carbon away or force extra hydrogen in, and neither process is simple, cheap, or forgiving of mistakes. For most of the 20th century, it also didn't need to be simple or cheap, because oil was abundant and comparatively easy to extract. Coal to liquids only made economic sense in a handful of extreme situations, a wartime blockade, or a country like apartheid-era South Africa that faced international sanctions and had almost no other option. China's own experiments with the technology in the 2000s and 2010s ran into exactly the problems you'd expect. Enormous water consumption, high carbon emissions, and a price tag that only made sense when oil prices spiked. One high-profile coal-to-gas project in the northeastern city of Fujian actually got built, then sat unfinished and mothballed for roughly a decade, starting in 2014, a casualty of cost overruns and environmental concerns that outweighed the payoff at the time. That's not a story of failure. It's a story of a genuinely difficult trade-off that simply hadn't tipped in coal's favor yet. What changed wasn't a single scientific breakthrough. It was the economics shifting underneath the whole equation, plus 20 years of incremental engineering nobody outside the industry was paying attention to. The pressure that changed everything. 2 things happened at once. First, the underlying chemistry got dramatically more efficient. Second, and more importantly, the world's sense of oil supply risk changed. On the chemistry side, coal-to-liquids plants run on one of 2 pathways. Direct liquefaction applies intense heat, hydrogen gas, and catalysts straight to coal, cracking it apart and rebuilding it into liquid hydrocarbons in a single, brutally energy-intensive step. Indirect liquefaction takes a gentler, more flexible route. It first gasifies the coal into a synthetic gas, a mixture of carbon monoxide and hydrogen called syngas, and then rebuilds that syngas into liquid fuel through a process called Fischer-Tropsch synthesis, originally developed in Germany in the 1920s and refined for a century since. Indirect liquefaction can use a wider range of coal grades and produces a cleaner, more predictable output, which is why most of China's newest plants lean on it. The scale involved is genuinely industrial, not experimental. China's Shenhua Ningmei plant, commissioned in 2016, processes roughly 44,000 tons of coal a day and turns it into around 100,000 barrels of synthetic fuel daily, not annually. Think of it less like a chemistry demonstration and more like a small refinery that happens to start with rock instead of crude. The newer HAMI project in Xinjiang, backed by that $24 billion investment from CHN Energy Investment Group, is being built to run both direct and indirect liquefaction side by side, aiming for production starting around 2027. What makes HAMI different from earlier attempts isn't just its size. It's designed to draw power from wind and solar installations built alongside it, which cuts into one of coal to liquid's oldest and fairest criticisms, that converting coal into fuel is itself an energy-hungry, carbon-heavy process. Nationally, China's coal to oil output has grown by roughly 24% between 2019 and 2023 alone, reaching about 11 million tons of synthetic fuel a year. Still a small fraction of the country's total oil consumption, but growing at a pace that wasn't happening a decade ago. That distinction matters. This isn't a lab curiosity anymore. It's an industry with real tonnage, real capital, and a real construction timeline behind it. The catalyst nobody saw coming. Coal to liquids isn't the only front China is working on to loosen its dependence on imported oil, and the second angle is stranger than most people expect. Researchers at the Shanghai Advanced Research Institute, part of the Chinese Academy of Sciences, have been developing a completely different approach, converting captured carbon dioxide directly into jet fuel range hydrocarbons using a specially engineered catalyst. Instead of starting with coal or crude oil, the process starts with waste CO2 and hydrogen split from water, then uses an iron-based catalyst laced with aluminum and potassium to force those molecules into long hydrocarbon chains chemically similar to jet fuel. The lab-reported numbers are genuinely striking for a process this new. The catalyst converts close to half of the incoming CO2, around 49%, into usable hydrocarbons, operating at a temperature of about 330 degrees Celsius and a pressure of roughly 290 pounds per square inch. For comparison, that's a lower pressure than a standard Fischer-Tropsch coal-to-liquids plant typically requires, which is exactly the kind of detail that makes materials scientists pay attention. A pilot-scale version of this CO2 to jet fuel process reportedly began operating near Shanghai in early 2026, with early production agreements already in discussion with airline partners. It's important to be precise about what this is and isn't. This is not yet an industrial-scale replacement for coal to liquids or crude oil refining. The volumes involved are a small fraction of what a facility like HAMI will produce, but it points at something coal to liquids can't offer on its own. A pathway to jet fuel that doesn't require digging anything out of the ground at all, just captured emissions, water, and enough renewable electricity to power the reaction. The technology isn't entirely without precedent either. The core chemistry, building hydrocarbons from a carbon source and hydrogen using a catalyst, traces back to the same Fischer-Tropsch principles developed nearly a century ago, the same ones powering coal to liquids plants like HAMI. What's different is the input. Where HAMI starts with solid coal mined from the ground, the Shanghai process starts with a molecule most industries currently treat as pure waste, carbon dioxide, that would otherwise be vented into the atmosphere. That distinction matters more than it might sound like on paper. A coal-to-liquids plant is, at its core, still extracting a finite fossil resource from the earth, just converting it into a different form before it's burned. A functioning CO2 to jet fuel process, if it scales, effectively runs the carbon cycle in reverse, pulling a greenhouse gas back into a usable fuel instead of releasing more of it. That's a fundamentally different long-term proposition, even if today it's operating at a tiny fraction of HAMI's scale. Put the two technologies side by side and a pattern emerges. China isn't betting on one single fix for its oil dependence. It's running the industrial-scale coal route and the emerging CO2 route in parallel, the same way it hedged its bets across multiple battery chemistries before settling into a dominant lead. That kind of redundancy is expensive in the short term. It's also exactly how you avoid getting boxed into a single point of failure twice. The world starts paying attention. This isn't a story happening in isolation, and the response from the rest of the global energy industry has been telling. Coal to chemicals and coal to liquids equities on Chinese markets surged by roughly 30% between late February and mid-March of 2026, as renewed instability in Middle East oil supply routes pushed investors to re-rate the strategic value of the sector. That's not a speculative bubble reaction. It's a market recalculating in real time how much a hedge against oil supply disruption is actually worth. South Africa's Sasol, the company that pioneered large-scale coal-to-liquids technology decades ago under apartheid-era sanctions, remains the technology's other major global operator, and its Fischer-Tropsch process is the same chemical backbone China's newer plants are built around. Qatar has pursued a parallel path with gas-to-liquids technology rather than coal, proving the same core chemistry, building liquid fuel from something other than crude oil. Works at industrial scale when the economics justify it. One energy sector analyst covering the space, discussing the broader shift industry-wide, described it as a structural change rather than a temporary arbitrage opportunity. Investors aren't treating this as a short-term hedge anymore, but as a long-term repositioning of how energy security gets built. Even countries without China's coal reserves are watching closely, because the underlying lesson isn't really about coal specifically. It's about whether a country can build energy security out of whatever domestic resource it actually has, instead of whatever resource happens to be cheapest to import. That's a question every major economy with a maritime choke point in its supply chain is quietly asking right now. Malaysia, Indonesia, and Singapore, the three countries that jointly manage the Strait of Malacca itself, have their own reasons to watch this build-out closely. Roughly a third of all global trade moves through waters they administer, which means any shift in how much oil actually needs to cross that strait changes the strategic calculus for everyone downstream of it, not just for China. The broader energy industry has been here before with a different fuel entirely. A decade ago, few analysts expected China to dominate global battery and electric vehicle manufacturing the way it eventually did. The shift looked speculative right up until it wasn't. Coal to liquids and CO2 to jet fuel technology are being watched with that same cautious attention now. Not yet proven at the scale that would reshape global oil markets, but backed by enough capital and enough strategic motivation that dismissing them outright would be premature. How big could this actually get? Scale matters enormously here, and it's worth being precise about where things currently stand versus where they're headed. 11 million tons of synthetic fuel a year sounds significant until you compare it to China's total oil consumption of more than 15 million barrels a day. Synthetic fuels currently cover a small single-digit percentage of national demand, not a majority. But the trajectory is what makes this worth watching. HAMI alone is being built to eventually process enormous volumes of coal into liquid fuel once it reaches full capacity post-2027, and it's just one of several megaprojects moving through construction and planning right now. If China's coal-to-liquids output continued growing at anything close to the 24% pace it posted between 2019 and 2023, the sector wouldn't just be a hedge anymore. It would become a meaningful, permanent slice of the country's total fuel supply within a decade. And that's the real strategic goal here. Not eliminating oil imports entirely, which isn't realistic given the sheer scale of Chinese demand, but building enough domestic liquid fuel capacity that a disruption at that narrow strait stops being an existential threat and starts being a manageable inconvenience. There's a useful comparison in how China approached coal power itself over the past 2 decades. Coal-fired electricity wasn't eliminated by the country's renewable build-out. It was diluted, pushed from being the dominant source of power to one option among several, as solar, wind, hydro, and nuclear capacity expanded around it. Synthetic liquid fuels look like they're following a similar early trajectory. Not a replacement for imported oil, but a second domestically controlled column standing next to it, growing quietly in the background while the headlines focus elsewhere. If that trajectory holds, the country most exposed to a single narrow waterway today could be meaningfully less exposed to it within a single decade, without ever needing that waterway to become any safer. Honest limitations. None of this happens without serious trade-offs, and it's worth naming them plainly rather than glossing past them. Coal to liquids is, molecule for molecule, a more carbon-intensive way to make fuel than pulling crude oil out of the ground and refining it conventionally. Even with renewable power, offsetting some of the process, converting solid coal into liquid fuel is inherently energy-hungry chemistry. Water use is a real constraint too. These plants are enormously thirsty, and China's coal reserves happen to sit disproportionately in its driest western provinces, which means water availability, not just coal supply, increasingly caps how fast this technology can scale. Cost is another honest barrier. Coal to liquids only becomes economically competitive with conventional oil refining when oil prices climb high enough or stay unstable long enough to justify the enormous upfront capital. The HAMI project's $24 billion price tag only pencils out if energy security is treated as worth paying a premium for, not just cheapest fuel wins economics. And the CO2 to jet fuel technology, while genuinely promising, is still years away from operating at anything close to coal to liquid scale. Lab and pilot scale success doesn't automatically translate into a global supply chain, and the fuel still has to clear the same rigorous aviation certification process every new jet fuel source has to pass. This also isn't a technology every country can simply copy. It depends on having large domestic coal reserves in the first place, which rules it out as a strategy for oil import-dependent nations that don't have China's specific resource base. The honest picture is a gap between what's technically achievable and what will actually be running at meaningful scale 5 or 10 years from now. Not a reason to doubt that the chemistry works, but a reason to stay skeptical of any headlines suggesting this replaces oil tankers overnight. It all comes back to that narrow stretch of water. 20 million barrels a day still have to pass through a channel 3 kilometers wide, and no single coal plant or laboratory catalyst changes that fact today. But every ton of synthetic fuel that comes out of a facility like Hami is 1 ton that never had to cross it, and multiplied across a decade of steady industrial build-out, that's the kind of unglamorous patient engineering that quietly rewrites a country's exposure to the rest of the world, long before anyone notices the headline changed. If stories like this are your thing, hit like and subscribe so the next one finds you. And here's a question worth sitting with. If a choke point barely 3 kilometers wide has been able to shape an entire nation's energy strategy for over 2 decades, what other single points of failure in the systems you rely on every day are hiding in plain sight, waiting for someone to finally engineer their way around them?